For this video, we're going to be discussing factoring two-term polynomials, also known as difference of squares. So, we're talking about a two-term polynomial. We're generally talking about something like x squared minus 9. Something with two terms where one of them is the x squared term and one of them is the constant. So, polynomials with two terms are only factorable if there's a minus sign between them. They have to be subtraction. And both numbers have to be perfect squares. If there's a plus sign between them, then those polynomials are prime. They cannot be factored. So like x squared minus 9 is factorable, but x squared plus 9 is not. That is prime. They also both have to be perfect squares. So in this case, x squared minus 9, the coefficient out front is 1, which is a perfect square. The square root of 1 is 1. 9 is a perfect square. The square root of 9 is 3. And x squared is a perfect square. The square root of x squared is x. So I'm going to show you two methods to solve this. The first is to use grouping. So using grouping is what we've been doing for factoring in all of our other types of problems with 4 terms or 3 terms. Okay, we're just going to add a step to it. So step 1, as always, is to look for a greatest common factor. Then this is the new step, we're going to insert a 0x term in the middle. Essentially, we're just going to put in the middle a term that has our variable and has a 0 in front of it. And then we're going to do what we did with a 3-term polynomial. We'll split the middle and then factor by grouping. So let's look at this example here, 48x squared minus 3. Well, they have a GCF, it's 3. Factoring out of 3 gets me 16x squared minus 1. Taking a look at this, I go, okay, 16 is a perfect square, x squared is a perfect square, 1's a perfect square, and there's a minus sign between them. So I know that this is factorable. So I'm going to rewrite this as 16x squared, and here's where I put in that plus 0x minus 1. And from here, I just factor this the way I factored all 3-term polynomials. Make my little x. On the top, I do 16 times negative 1, and I get negative 16. On the bottom, I put 0. Try to find two numbers that multiply to negative 16 and add to 0. Well, the only way for two numbers to add to 0 is for them to have the same value but different signs. So in this case, two numbers that multiply to negative 16 and adds to 0 are positive 4 and negative 4. And now I can just follow the same process I've done for other problems and go 16x squared plus 4x minus 4x minus 1. Group my first two and my last two. For the first two, their GCF is 4x. And if I divide out that 4x, I get 4x plus 1. For my last two, my GCF is negative 1. Factoring that out, I get 4x plus 1 again. So when I regroup at the end, I get 4x plus 1 and 4x minus 1. Similarly, if I take a look at my next example here, I've got 25p squared minus 9. They do not have a GCF, so I don't have to worry about that. 25 is a perfect square, p squared is a perfect square, and 9 is a perfect square, so I know this can be factored. So I'm going to rewrite this as 25p squared plus 0p minus 9. Pull up my x. 25 times 9, got negative 225, and on the bottom, 0. Once again, since the bottom is 0, the two numbers have to be the same. So the two factors of 225 that are the same number are positive 15 and negative 15. So I'm going to say 25p squared plus 15p minus 15p minus 9. The GCF of the first two is 5p. Factoring that out, I get 5p plus 3. The GCF of the last two is negative 3. Factoring that out, I get 5p plus 3 again. So my final answer is 5p plus 3 times 5p minus 3. Okay, let's look at these last two on this page. 32x squared minus 18. Okay, 32x squared and 18, those are both divisible by 2. When I divide those by 2, I get 16x squared minus 9. All perfect squares here. Put my 0 in the middle. Go to my x. 16 times negative 9 is negative 144. 0 on the bottom. Two numbers that multiply to negative 144 and add to 0 are 12 and negative 12. So I'll go rewrite down here. Okay, GCF of the first two is 4x. GCF of the last two is negative 3. Okay, what I get when I divide these by 4x is I get 4x plus 3. And then in my other set of parentheses is what I'm dividing by, 4x minus 3. And then last one on this page, I've got 49x squared plus 81. They don't have a GCF. 49 and 81 are both perfect squares, but I have a plus sign. So this cannot be factored. So I just say, this is prime. And I'm done. So that's method 1. Method 2 is a shortcut. We're calling this the difference of squares shortcut. So the way the difference of squares works is you're going to start, once again, by factoring out a GCF. And here's where it's going to get different. Second step is to square root both terms. Then we're going to take those two resulting terms, we're going to put them in two sets of parentheses, one with a plus sign and one with a minus sign. So let's see how that works. This actually becomes a really quick problem that way. 64x squared minus 121. Those do not have a greatest common factor. So I skip the greatest common factor step. So I go straight to my square roots. So I'm going to square root the first one, and I'm going to square root the second one. The square root of 64x squared, square root of 64 is 8, square root of x squared is x. So I put 8x in both sets of parentheses. The square root of 121 is 11, so 11 goes in both sets of parentheses. And then the first set I put a plus, the second set I put a minus, and I'm done. That's my answer. Real quick shortcut. Second one here, 324x squared minus 100. These are both divisible by 4. So I'm going to bring 4 down so I don't forget about it on my answer. 324 divided by 4 is 81. So I get 81x squared. 100 divided by 4 is 25. Both perfect squares. So I'm going to go square root, square root. Square root of 81 is 9x. Square root of 25 is 5. Minus on the first one, plus on the second. Doesn't actually matter which one gets a minus, which one gets a plus. That is our answer. Next one down here, 225x squared plus 196. No GCF. They are both perfect squares, but once again, that plus sign tells me that one is prime. So for a try it problem, I'm going to leave you with this last problem on the page here. 75x squared minus 12. You can use either method you want, whether it's difference of squares, the shortcut, or it's the long way. Try factoring this out and see what you get.